All right, so hopefully my sound is working this time. These are the alloy notes. So what you want to do is find your notes place and let's just get started here. The definition is going to be the first thing that we write down for alloys, and alloys are a solid, homogeneous, should be a comma there, solid homogeneous mixtures of metals with metals, or metals with carbon. Okay, so most metals, or most alloys, excuse me, are metals with metals, but a very common one is steel, and that's iron with carbon. There might be other metals in there, but the most important thing to know here is that these are mixtures, and they're not only mixtures, they're homogeneous, okay? That also means they are solutions, because solution is another word for homogeneous mixture, so remember that. All right, so we're going to do a little bit of thinking back on some of the stuff that we've learned in our previous units. Okay, so first of all, we have talked about metals give electrons to nonmetals for stability. Okay, and when that happens, they form ionic compounds. Okay, so metals give electrons to nonmetals. That makes both of them stable, and then they have opposite charges and they stick together. So an example would be NaCl. Sodium gives an electron to chlorine. Sodium chloride is the resulting compound. Okay. We have also learned about nonmetals. Share electrons with nonmetals to form covalent compounds. So another way to fill up that valence shell and become stable is by sharing electrons. So nonmetals share with other nonmetals to form covalent compounds. Example, N2O5. Okay, and remember we named those compounds a little bit differently. We use prefixes, dinitrogen pentoxide. Okay, but what about, let's not underline that. What about metals with metals? We did metals and nonmetals, we did nonmetals and nonmetals, we haven't done metals with metals. Well, they do not form compounds or bonds. They only form mixtures, and these are called alloys. They only form mixtures, and these are called alloys. Okay, purpose of alloys. Purpose of alloys. Why would we mix metals in the first place? Okay, well, first of all, alloys are created to have, alloys are created to have better properties than pure metals for various uses. Alloys are created to have better properties than pure metals for various uses. Now, depending on what you're using it for, better properties can mean lots of different things. So let's just give some examples. These improved properties could include corrosion resistance. Having some typing issues today. All right, corrosion resistance, meaning it won't rust. So if you're building a pier using some metal out in the ocean, you don't want that to rust or it'll just fall apart. So corrosion resistance is really important for you. Okay, increased strength. Increased strength, won't break. Decreased melting point. Easier to work with. So some metals have really high melting points, and it's really hard to work with them because you have to work at extreme temperatures. But if you make them into an alloy and mix them with something else, then that alloy becomes moldable at a lower temperature, and that makes it easier to work with. A more desirable color. More desirable color. Just having issues this morning, okay? This could be for jewelry. Hopefully you've heard of white gold and rose gold and yellow gold. I mean, that's personal preference. Or fixtures, so doorknobs and hinges and handrails, all of those are made to be a specific color. Better sound. If we're making musical instruments, number one thing that we care about is what they sound like, okay? So better sound. Lighter weight. Lighter weight. This would be for tall buildings or airplanes. Oops. Okay, you want something that's lightweight but still strong, okay? So those are just some examples of properties. It depends on what you're using the mixture for, the metal for, what properties you're gonna be looking for, okay? All right, example alloys. Let's just go through a list and that'll be the end of these notes. So steel, and there's a lot of types of steel. They have different types of elements mixed into the homogeneous mixture with the iron. All of them have an iron base though, so iron would be that solvent because it's the largest component. Bronze, that's a mixture of zinc and tin. Sorry, copper and tin, okay? 14 karat gold, we're going to talk about that more, but that's a mixture of gold and silver. It could have nickel, it could have copper. It just depends on what color you want that gold to be. Okay, brass is copper and zinc. We're going to make some brass in a lab. Sterling silver. All sterling silver has a little stamp on it that says 0.925 because 92.5% of sterling silver is silver. The other 7.5% is other elements to make it a little bit stronger. Okay. Cast iron. Cast iron is just iron with carbon, I believe. You just heat the iron to a pretty extreme temperature and then put it into a high carbon environment like oil or coal, and it absorbs some of that carbon into its structure as it's cooling. Okay. And then this isn't a super creative name, but nickel aluminum alloys are super common in our industry today. We don't really have a way to predict what properties we're going to get when we mix elements, when we mix metals and make alloys. So it's a guessing game, but nickel aluminum alloys have some really cool properties and we use them a lot today, but instead of a fancy name, we just call them nickel aluminum alloys. So that's the end of these notes and I will see you in class.